Let's start with a very important concept, how applications are structured. Imagine you are building a system like an online shopping app. You will have user login, product catalog, orders, and payments. Now, in a monolithic architecture, all of these are combined into one single application. So if I draw it on the board, it's just one big block. Everything is connected and runs together. The advantage? It's simple to build. But here's the problem. If one part fails, like the payment system, the entire application can crash. Also, updating one feature means redeploying the whole system. Now let's move to microservices architecture. Instead of one big system, we divide it into small independent services: user service, product service, and payment service. Each service runs independently and communicates through APIs. Why is this powerful? You can update one service without affecting others. You can scale only the parts that need more resources, and teams can work independently. This is why companies like Netflix and Amazon use microservices. Which architecture do you think is easier for beginners? Which one is better for large-scale systems? Now we must ask, how do these parts communicate? That's where APIs come in. Let's talk about RESTful APIs, which act as the communication bridge between systems. Think of it as a waiter. You, client, request food. The waiter API sends your request. The kitchen server prepares it, and the waiter brings back the response. REST stands for Representational State Transfer. It's a standard way of designing APIs using HTTP methods: get, post, put, and delete. Example: if you open a shopping app and view products, your app sends a GET request to the server. This allows systems to communicate easily. REST is lightweight and supports scalability. Others include SOAP, but REST is more popular. What happens when you refresh an app? Traditionally, applications follow a client-server model. The client is your phone or browser. The server is a computer that processes requests. For example, you open Facebook, your phone sends a request, the server processes it, then sends back data. This model is still widely used. But there's a challenge. You need to manage servers' maintenance, scaling, security. Now comes serverless computing. Despite the name, servers still exist. But you don't manage them. Instead, you write code, and a cloud provider like AWS runs it for you. This is function as a service. Advantages: no server management, automatically scales, and you pay only when code runs. Imagine a login system that runs as a simple function. When is serverless useful? Small applications and startups with limited resources. The limitations: less control, and it can be harder to debug. Would you prefer managing your own server or letting the cloud handle it? Now let's connect everything. If you were to design a modern application, would you use monolithic or microservices? How would your services communicate? This is what real developers think about. Your goal is to design systems. By the end of this lesson, you should be able to analyze architectures, understand when to use monolithic versus microservices, and design scalable systems. These are real-world skills that companies expect from IT professionals. Let's start building the future of software.